Okay, so welcome to 6.5, Dividing Monomials. So remember we had an exponent rule that said a to the m times a to the n. When you multiply and the bases are the same, you add those exponents. So that's one of our exponent rules. Well, now we have one for division, and if you have the same base, you're going to subtract the exponents. So our first problem over here, here's the rule, the exponent rule. That's what it says. But we have x to the 15 divided by x to the 10th. The bases are the same. They're both x. So we're going to subtract the exponents. 15 minus 10, that's going to be x to the 5th. And we're done. All right, let's go to this problem over here. We have 6 to the 14th divided by 6 to the 5th. The bases are both 6. So we're going to subtract those exponents. 6 to the 14 minus 5. So you keep that base, you keep the base the same, and then you're just subtracting those exponents. 14 minus 5 is 9, so we have 6 to the 9th. Now those are both numbers, so we could multiply it out, but it's going to be some huge number, and I'm not interested in figuring out what that is, so I'll just write 6 to the 9th. If the numbers are fairly small, then we usually multiply them out. All right. Our next problem, we have x to the 18th over x to the 22. Now you'll notice that we have more x's in the denominator. So what we're going to do is we're going to go the other way. We're going to write this as 1 over x to the 4th. So you could think about, 18 x's in the numerator and 22 x's in the denominator, and then start crossing off x's, but that'd be a lot of work to write that out. But there are going to be 4 more x's down in the denominator than the numerator. So all the numerators canceling out, and then you have x to the 4th down in the denominator. All right, the next problem is going to work similarly. The bases are 12. So you have 15 of them in the numerator, 30 of them in the denominator. So all of the numerators are going to cancel out, and our leftovers, the 12s that we have, they're going to be in the denominator. It'll be 12 to the 15th. And again, I could figure out what 12 to the 15th is, but it's going to be some huge number. I'm just going to leave it like that. All right, now we want to talk about the 0 exponent. If you had a over a, that would just equal 1. If you had x squared over x squared, that would just equal 1. So if you have the same thing in the numerator as the denominator, it just equals 1, right? All right, well, let's say you have like x cubed over x cubed. You know that's going to equal 1 because of what we were just saying. But we have a rule that says, well, in division, if the bases are the same, and they are in this case, then I could subtract those exponents. So I'd have x to the 3 minus 3. Well, 3 minus 3 is 0. So x to the 0 has got to be equal to 1. So sometimes that's unusual for students because they're like, there's a 0, but that's the way it works, and that's why it works that way. The rule says if you have a base to the power of 0, that's just going to equal 1. Now there is a little thing in here. A cannot be 0. The base can't be 0. But we're not going to have 0 bases. We're going to assume all our bases are not 0 for these problems. Okay? So that's another exponent rule. So it's when you have an exponent of 0. All right, so these problems are kind of fun. So 15 to the 0, that's just going to be 1. M to the 0, that's just going to be 1. Now notice here you have 11z, but the whole thing is raised to the power of 0. That's just going to be 1. And then here you have a little bit more, but it's all in the parentheses. It's all being raised to the power of 0. So that's just going to be 1. Okay? All right. So our next exponent rule is right here. We can look at the exponent rule that we learned earlier about if you have AB raised to the power of m, that you can make that a to the m, b to the m. It's kind of like distributing. You're bringing that exponent of m and applying it to all the bases that are inside the parentheses. Now it's the same thing here, but it's division. So the a gets the m and the b gets the m in the denominator. So we'll do some examples. Our first one, we're going to take 5 and we're going to square that, and then it's going to be over 8 squared. So both the 5 gets the square and the 8 gets the square. Now those numbers are fairly small, so we're going to multiply them out. 25 over 64. And that'll be our answer. The next problem, we have p to the 4th over 10 to the 4th. Now, do we want to multiply out 10 to the 4th? We can. That would be a choice that you would make. I think they would probably multiply them out because powers of 10, that's just going to tell you how many zeros you have. So 4th power, it's going to have 4 zeros. Now our last one here, that's going to be m to the 7th over n to the 7th. And that's all we can do with that. It's all done. All right. My screen's having a lot of trouble here. Okay. Now we're going to combine some of the rules that we've learned and work with simplifying these problems. So we look at the problem, we do what we think we should do first. On this first problem with the m's, see those parentheses? I want to get rid of those. So I'm going to make that m to the 20th, because I'm multiplying there, 5 times 4, over m to the 7th. And now I can use that rule that we just learned about subtracting, make it m to the 13th. I have more m's in the numerator, so that's going to be just m to the power of 13. All right, let's look at the next problem. We have n to the 12th in the numerator, and then in the denominator, we're going to multiply there that 3 times 4, so n to the 12th. But what did we just learn? That anything is the same in the numerator as the denominator, that's just going to equal 1. Now you can think about 12 minus 12 being 0, but it's going to be 1. All right, so now we have two choices on this last problem. We can either simplify in the parentheses first, or we can bring in the exponent that's outside that 4. We can bring that in first. I'm going to simplify in the parentheses first this time. So I'm looking inside the parentheses. I have r to the 5th over r cubed. That's going to be r squared. I didn't do anything with the 4 yet, so that's just out there on the parentheses. Now I'll bring in the 4. We're going to multiply there, and so it's going to be r to the 8th power. And then that one's done. Okay. Now, you might think, well, oh, I'll do the same thing on this next problem here. But the problem is you don't have like bases, right? So the only thing you can really do is bring in the 4. You're going to have to bring it into the 3 and that 2. So the answer is going to be a to the 12th over b to the 8th. And all we did was get rid of the parentheses, but that's the simplifying there. So that's what we want to do. Can't do anything else because a and b are different bases. Okay, now this 2, that has an arrow already, all right, we're going to bring that into all the bases. Now sometimes this is confusing, but the 7 gets squared. The x cubed is going to get squared. That's going to make it x to the 6th. The 9's going to be squared. And then the y is also going to be squared. Now remember, that's y to the 1st power there if you want to put a 1. We are going to multiply those bases out. So 49 x to the 6th over 81 y squared. And that one will be done right there. All right, I think we have one more here. We have the a's, lots of a's. So we're going to make that a to the 6th, because that 3 times 2 there. Then we're going to have times a to the 8th. That was the 2 times the 4 there. All over a to the 20th. That was the 4 times the 5 there. Okay. Now in the numerator, we can make that a to the 14th. You have to switch your thinking. Now we're not multiplying, we're adding those exponents. So when you multiply like bases, you add the exponents. Over a to the 20th. But we're going to reduce that, we're going to simplify it. There's more a's in the denominator, so it's going to be 1 over a to the 6th. Power. There we go. I think there's one more problem. And then we're going to stop and go to, well, maybe we can finish it. Let's see. So we're going to have, this one's going to be kind of complicated for what space I have. So I wish I could write it someplace else. We'll see what I can do. I'm going to take that 2, I'm going to apply it to the 3, so that's going to be 3 squared, which is 9. I'm going to have r to the 6th, and then times r to the 21st, all over r to the 9th, because you're going to have the 3 times the 3. Then that's going to simplify to be 9 r to the 27 over r to the 9. I'm almost done. Where can I write it? I'll write it down here. It's going to be 9 r to the 18. Because 27 minus 9 is going to be 18. And that one is done. All right, let's see if we can keep going here. We'll see if we can get this all in one video. Now we're going to divide these monomials. So in the first one, I have 42y to the 9th divided by 6y cubed. I can write it with the division symbol, but it might be easier to see this way. When I have those coefficients, 42 divided by 6, that's 7. Then I deal with the variables. And because they're both y, I'm going to subtract those exponents. There's more in the numerator this time, so it's going to be 7y to the 6th. So we're looking at the coefficients, and we're treating those like numbers. So 8 goes into 72 9 times. Now it is negative. That means it's going to be negative. Now look at the a's. Do I have more in the bottom or the top? More in the bottom. So a to the 5th in the denominator. And look at the b's. More in the denominator, so b. It's not written very nicely, but that's the answer. Okay, I think we've got another one. So, oops. All right, well, 16 doesn't go into 24, but they're both divisible by 8, right? So 8 goes into 16 2 times, 8 goes into 24 3 times. So I'm going to have a 2 in the numerator. I'm going to have a 3 in the denominator. Now let's look at the a's. More in the top, right? A to the 6th. Look at the b's. More in the denominator, b squared. So that's how that one goes. Let's see if I have any more problems. Come on, scroll for me. All right, I think we just have a couple more problems here. So 28 and 49, they're both divisible by 7. 7 goes into the 28 4 times. 7 goes into 49, 7. So I'm going to have, we'll do this like we did the last one, 4 over 7. Now look at the x's. More in the bottom, x to the 4th. Look at the y's, more in the top, y squared. And we're done. All right, this next problem right here, we're going to have to do some multiplying. So I'm going to multiply the numerator. Now we've done that before. So 6 times 4 is 24. You multiply the coefficients. It's going to be a to the 6th power. Remember to add those exponents. B to the 10th. All over, and then I'm just going to write 12a to the 5th, b to the 8th. And then I can finish this problem by doing this division. 12 goes into 24 2 times. I have an a in the numerator and b squared in the numerator as well. So that's it right there. I think that was our last problem. So enjoy doing the homework, and we'll see you in class.